Okay, today we are going to talk about classifying matter. So we're going to walk through this. You may, if we were in class, have a foldable option. We may have this graphical organizer, or you may have a digital graphical organizer you can complete. So based on whatever we're doing, that's what we're going with. But the notes are all going to be the same. So regardless of what format we're looking at, same notes. So let's go ahead and check this out. So the first thing we want to look at is talking about matter. Now, matter is anything that has mass and it has to take up space. Remember, saying space is the same thing as saying we need volume. Now, matter is then broken into two categories, pure substance or mixture. So let's go ahead and talk about a pure substance. When I'm talking about a pure substance, it only has one type of matter. It can only be made up of one quote-unquote thing. Okay? Is homogeneous only. And that's saying that it's the same throughout. So any pure substance is the same throughout. Another thing I want you all to note here that usually comes up is that when I'm talking about a chemical formula, there is no plus sign. We'll look more at that when we look at some examples and things here in just a minute. Now, pure substance can then be broken down into two categories, an element or a compound. So let's bump over to the element first. Now, an element can only have one type of atom. Now notice, this is an atom. This is one type of matter. So that's one of the big differences here. For an element, we're going to find it alone on the periodic table. What do I mean by alone? My periodic table out here. I mean, it's going to be in one of these individual boxes. So it's not going to be two things together. It's only going to be one of these. If it's only one of those, then it's going to have a single capital letter. When we are talking about elements, if it's something like hydrogen, it's only a capital H. But if it's something like lithium, it's a capital L, lowercase I. So only one capital letter per element. So we just need a single capital letter in a chemical formula. Now our other option for a pure substance is to talk about a compound. So a compound has to be made of two or more types of atoms put together chemically. Now, it's important that we say chemically here because if it's put together physically, we'll see in just a second, we're going to consider that a mixture. So it being chemically combined means that it is bonded together. It's not like mixing up batter for cupcakes. It is bonded. It has gone through some sort of chemical process to put those two elements or more than two elements together. Elements change and have a new set of properties. When we're talking about, let's say, potassium, that is something that we cannot even really leave out because it's so reactive to water that it will react to water vapor. But people are like, Ms. Eisen, I eat potassium all the time. Well, you eat potassium in a compound. So lots of things that you're eating from bananas or raisins, things like that, you're actually ingesting something that has that in a compound, and it breaks up into what we'll talk about a little bit later, things called ions. So when you're talking about just potassium or something like that, how we use that colloquially, so in everyday world, is different than how we're going to use that in science. So just keep that in mind when we're talking about this. So our chemical formulas include more than one element symbol with no plus sign. We don't need a plus sign because a plus tells us that it's put together physically. Okay? We need to make sure this is put together chemically. So those are our pure substances. Now let's talk about our other section of matter here, which is our mixtures. So a mixture has two or more types of matter. So two things physically put together. Again, that physically is important here because that's going to tell us the difference between a mixture and a compound. Physicals mixture, chemicals compound. CC, chemicals compound. In a mixture, substances do not change properties. That's another difference. In a compound, we have a new set of properties. In a mixture, we are not changing our properties. All compounds are homogeneous. Mixtures can be heterogeneous or homogeneous, and we'll talk about that in just a second. And mixtures have a plus sign when you're using element symbols. So if you're mixing something together, you're adding it together, so you're going to have a plus sign there. Now let's break down our two types of mixture options here. So we have our heterogeneous mixture, which is different throughout. And usually you're going to see a visible difference. So you're going to be able to see the separate things. That one people are usually pretty comfortable with as far as classifying. The one where usually people get a little tripped up is when we're talking about a homogeneous mixture. Homogeneous is the same throughout, has no visible difference, and substances still do not change properties. Now, the reason I put this is we're going to talk about some things like Kool-Aid. When you make Kool-Aid, you're going to have your water, your Kool-Aid packet, and for me, I like to put sugar. Apparently some people don't. Not my style, I like sugar in there. But you're going to mix those together. And what's going to happen with that powder and that sugar is that it's going to dissolve. But if you spill some Kool-Aid out on the table, when that water evaporates, you're going to be left with those flavor crystals and sugar crystals on that surface. So I didn't change the properties of that sugar or that Kool-Aid mix or that water, but I mixed them together so they looked different than they originally did, but they look the same throughout, or they should. If they don't, they need to stir some more, or you put too much sugar in it. Okay? So that's kind of our setup. So let's look at some examples. Let's check out my bracelet. Okay? So this is a pure gold bracelet. And let's talk about how to classify it. So we know it's matter. It has mass. It takes up space. So then I need to look at the question that I've written here. Does it have more than one type of matter? So my focus here is going to be on that word matter. It's only gold. If you're thinking about the periodic table, just gold is just AU. So, does it have more than one type of matter? No, it does not. So that makes it a pure substance. So I know that gold now is a pure substance. And I know that because it has one type of matter. Now I have to decide if it's an element or a compound. Now my question here says, does it have more than one type of atom? So I'm shifting from looking at matter to looking at atom. So if I give you the chemical formula like I have right here, I can look at how many capital letters I have. So AU, I only have a capital A, so I only have one type of atom. So my answer here is going to be no. So I know that this is an element. So this is my answer as to what I would classify gold as, and this is my Y. Now remember, if it's a pure substance, I'm always going to say that it's homogeneous And for this, it's because it's a pure substance. So this would be my 3 answer choices. Say I gave you a multi-select question and I said, classify gold. These are the 3 things you would choose. And then if we were doing a lab or a practice or something like that where I asked you to justify or explain, these little inset sections are your why. Okay, let's talk about another example. Let's say I have these candies. Okay. Different colors, different flavors. So let's go ahead and classify these candies. We know that they're matter because they have mass and take up space. So let's look at our next question. Does it have more than one type of matter? So let's think about these. We know that it has sugar, some sort of gelatin, some sort of food coloring, some sort of flavor. So there's several things going on here. So does it have more than one type of matter? Yes, it does. So that's going to make it a mixture. It has more than one type of matter. And I'm going to make sure that I write physically combined on here to remind myself. Now, let's break that down into this next one. So now my question is it the same throughout? Now, some people are like, well, Miss Austin, it's all the same kind of candy. There is a visible difference here. We got red, yellow, orange, green, some pinks. But if you eat these, there's also a flavor difference here. So we know that there are differences happening. So since they're not the same throughout, no, these are a homogeneous mixture. Or sorry, heterogeneous mixture. Pointed to the right place, said the wrong thing. And the main way we could know is that they are visibly different. So if I was to classify these candies, I would say that they're a mixture because there's more than one type of matter physically combined. And I would say that they're heterogeneous because there's a visible difference between these. So we gave our example of gold over here. And then we gave our example of candies over here. Let's see what else we have. Let's check out this Gatorade. So I'm going to talk about the Gatorade that's in the bottle. My first question is, does it have more than one type of matter? Now, this looks like one thing, but if I were to check out our ingredients, it tells me that we have water, sugar, dextrose, citric acid, salt, and several other things on here. So there's definitely more than one type of matter in here. So if you're looking at a product, you can always check out its ingredients list to see if we have one or more than one thing. So the question is, does it have more than one type of matter? Yes, it does. So we know that this is going to be a mixture. So mixture, more than one type of matter, physically combined. So I got my mixture. So now my question is it the same throughout? Well, in theory, whatever you take a drink of up here should taste the same as whatever you take a drink of down here. It should be uniform. Lots of times that's what we'll also say when we mean same throughout. So yes, it is the same throughout. So that's going to be a homogeneous mixture. So if I'm classifying Gatorade, I'm saying that it's a mixture because there's more than one type of matter physically combined. And I'm saying that it's homogeneous because it's the same throughout. So I'm going to leave myself a little down here, a little reminder. So now let's check out our last example. And this is just some regular old table salt. Okay. And table salt, I'll go ahead and give you the formula for. So we have table salt, which is also known as sodium chloride, which is NaCl. So the very first question is, does it have more than one type of matter? Is there more than one thing going on? So lots of times whenever I give people the chemical formulas when they get a little confused here, don't let that throw you off. There's no plus sign, so this is only one type of matter. It's just sodium chloride, nothing else. So does it have more than one type of matter? No. So our first thing is that it's going to be a pure substance. One type of matter. Remember, if it's a pure substance, we also know that it's homogeneous. Automatically, if I say pure substance, I say homogeneous. If it's only made up of one thing, it has to be the same throughout. So, pure substance, homogeneous. Now let's check out our last question. Does it have more than one type of atom? So one of our clues here is, where did it go? Oh, more than one element symbol with no plus sign. So I have capital N, lowercase a, capital C, lowercase l. No plus sign between those. So I have two atoms here. I have a sodium and a chlorine. So I have more than one type of atom. Yes, so this is a compound. And we have two atoms put together, and remember this part's important, chemically. So if I were to be classifying table salt, I would say that it's a pure substance, a homogeneous, and it's a compound. So write my example down there. So now we've looked at an example of an element in our gold, a compound in our table salt, a heterogeneous mixture in our candies, and a homogeneous mixture with our Gatorades.